Right, I want to make a real quick video to go with the two-way table notes for Chapter 10. So, creating a two-way table. There are 200 sophomores at a school, 80 boys, 50 students with a driver's license, 90 girls don't have a license. So, the things you want to remember when you make a two-way table. First of all, two-way tables should have two distinct categories. Results of the spinner, like if it's 1, 2, 3, 4, 5, or whatever, if it's colors, green, red, yellow, red, blue. Yes and no is a big one. If you can make it like yes, no, like is it a boy? Yes, no. Is it a girl? Yes, no. That's going to be crucial. Versus saying like, is it a boy? Driver's license. I'll talk about that a little bit more, I guess. But you want it like to be like a light switch. It's either this category, this category, this category. You don't want to have some going in columns and some going in rows. Otherwise, that'll screw you up. So your grade in school, if you're a freshman, sophomore, junior, senior. What kind of flavor you like. Do you like strawberry, blueberry, raspberry? Again, they should all sort of be things that go together that can be broken into different categories. Like in this example, we have driver's license. Do you have a driver's license? Yes, no. Are you a boy? Yes, no. We wouldn't want to say, do you have a driver's license? Yes. Are you a boy? Yes. Because that would get confusing. We would have two different topics. So we want one topic for rows and one topic for columns. The next thing is, if only one category is mentioned, it's a total. So if we go back up here, there's 200 sophomores at a school. That's only one thing it mentions. And that could be all the driver's license, 200 people with the driver's license, 200 people are boys and girls, so that's going to be a total. 80 boys. It doesn't say anything at all about them having a driver's license. So that has to be a total. We can't put it in the middle. We'll call this the middle, absent the totals. So it can't go in the middle unless it mentions both things. So in this example, it just said 80 boys in total. It has to be a total. 50 students with a driver's license is a total. Again, it doesn't say anything about if they're a boy or a girl, so it's got to be a total. 90 girls don't have a license. 90 girls that don't have a license. Well, now it mentions that they're a girl and they don't have a license, so it can go in the middle. And it will. Now from here, we just need to use simple arithmetic to fill the rest of this in. Well, we wouldn't want to start with there's two unknowns. It could be 50 and 0 or 40 and 10 or 30 and 20. We have no way of knowing it, but there's only one way we can add up to 200. If we're spotted at 50, this must be 150. And if this is 150, well, this must be 60. And if this is 60, this must be 20. And if this is 20, we got 30, and then this is 120. So when you're done, I would suggest you add up the columns to make sure that they add up to the totals, and add up the rows to make sure that they add up to the totals. Don't just add one or the other, because it could end you in the wrong spot where you think you might not catch an error, but if you add the rows and the columns, you'll definitely catch any errors that you have. So that's just creating a two-way table. Then we can answer some basic probability questions, which are a little bit different than unions and intersections, and versus or questions. This verbiage, unions and intersections, won't come up until integrated 2, but and versus or, obviously you should know and versus or already anyway. So basic probability, we're essentially asking everybody, hey everybody, what's the probability that you have a license? And we would say it looks like 50 out of 200 people. By the way, we need a ratio here. You can't just put 50. You need to say 50 out of how many. And I'll show you why later, because that can have some impact. Sometimes we ask everybody, sometimes we ask a subgroup. What's the probability of being a girl? Again, hey everybody, are you a girl? 120 out of 200 respond affirmatively to that. So basic probabilities are pretty easy. They ask everybody. Whereas unions and intersections are a little bit more specific. Intersection questions are and. You have to be in this category and this category, whereas it has to be in both sets. Whereas unions are or questions. They can be in one set or the other. So some examples. What's the probability of selecting a boy with or and a license, right? You have a boy and a license. Well, it looks like there's 20 boys that they're boys and they have a license. One way to do this is, here's all the boys, and here's all the people with licenses. So I gave this hash for a boy, and I gave this hash for having a license. They have to have both checks. They have to have the boy check and the driver's license check. So it's going to be 20 out of 200. What's the probability of selecting a girl or someone with a license? Well, I'll do the same thing. Uh-oh, I did not mean to do that. What's the probability of selecting a girl? Well, here's girls, or someone with a license. Here's people with a license. Now this is an or question. It's not an and question. So these people count. Even though they're boys, they do have a license. So there's 20. These 30 girls with a license certainly count because they meet both categories. So there's 50. And these people count. Even though they don't have a license, they are a girl. So an or question is more expansive. It includes more people. So I would say 20 plus 30 is 50, plus 90 is 140 out of 200. And hopefully you can see again. An and question, they have to have both hash marks. An or question, they have to have one hash or the other. So let's go to 5. What's the probability of selecting a girl without a license? Essentially we're talking about they have to be a girl and they have to have no license. Well, here's girls. Here's people with no license. They have to be both. So I would say it's 90 out of 200. And again, this really is like a language thing more than a math thing, the difference between and or. What's the probability of selecting a boy or someone without a license? Well, here's boys, and here's someone without a license. And again, it's or. So these people, or these people, or these people. So 80 plus 90 is 170 over 200. One thing I'll show you real quickly too is called the complement. It doesn't mean you look nice today, but I'm sure you do. The complement essentially says this. I want to know how many people are a boy or have a license. Well, these 30 people are girls with a license. So I don't know if it says that right. I want to know if people with boy or someone without a license. These 30 people are they're girls and they have a license, right? So they don't meet either category. So I can just subtract 200 minus these 30 because I know everybody else must be a boy or have a license. So that's known as the complement when you sort of take the opposite. All right, conditional probability. Conditional probability is the idea that probability may change as conditions change. Essentially, you're asking the probability for a subset of the entire population. So given a sophomore, what's the probability of them having a license? Now, we know we're talking to a sophomore. None of these people matter. None of these people matter. These people don't matter. And quite frankly, these people don't matter either, right? We're only talking about sophomores. We know we have a sophomore. So the conditions have changed, so the probabilities may change with it. We already know that we're dealing with a sophomore, and there's only 100 of them. We're not starting with 440 students. We're only starting with 100 sophomores. Only 10 of the sophomores have a license, so our probability is 10 out of 100. Note, if we asked, what are the odds of selecting someone having a license? It's 140. Right, now we can sort of go back over here. What if we asked, what are the odds of having a license at all? Well, you can see it's 140 out of 440. That would assume we asked everybody. And if we asked what are the odds of selecting a sophomore with a license, well, it would be 10 out of 440, right? Because we'd be asking everybody. But that is not what was asked. What was asked was, given that we're talking about a sophomore, so this is the only column that matters. So given someone with a license, again, these are the only people that matter. These people have licenses, nobody else does. So actually the total matters there as well. So given someone with a license, what's the probability of choosing a senior? Well, there's 140 people with a license and 80 of them are seniors. Given a junior, so now we only care about this column right here. So given a junior, what are the odds of having a license? Looks like 50 out of 100. Given a freshman, we only care about this column. What are the odds of having a license? 0 out of 150. By the way, this concept is known as mutually exclusive. The concept that two things cannot happen at the same time is known as mutually exclusive. The odds of a mutually exclusive event happening are 0. For instance, how many people are in 31 and in room 32 right now? None. You can't be in 31 and in 32 at the same time. That's mutually exclusive. And the last thing I want to go over was association. Checking for association is essentially checking to see if one parameter influences the other. For instance, if I ask 100 teens if they want to do chores, 0 of 100 would say, yeah, like no one wants to do chores. If I offered one whole cent, I would still get 0 out of 100 responding yet. Oh yeah, I'm sorry. I'd still get 0 out of 100 saying yes. I apologize. I had a little brain fart right there. This means there's no association, as the numbers didn't change because the money had no impact on their willingness to do chores. However, if I offer $1,000, I'd probably get 100 out of 100 kids saying they wanted to do it. And the numbers would change from 0 to 100, so there would be an association. Somehow that money is associated with their willingness to do work. Whereas in the first one, that penny, there was no association. That penny didn't make them want to do the work any more than they had before. So to check association, we're going to ask one subgroup a question. So given a freshman, how likely are they to have a license? So freshmen are 0 out of 150, or 0%. And then we're going to ask different subgroups the same question. So we'll ask the sophomores, the juniors, and the seniors the same question. So hey, sophomores, how likely are you to have a license? And this, they would say 10 out of 100, which is obviously 10%. The juniors would say 50 out of 100, which is obviously 50%. And the seniors would say 80 out of 90. I'll grab a calculator. 80 out of 90 is 89%. So did these numbers change? Yeah, I would say they changed significantly from 0 to 10 to 50 to 89. So we'd say there's an association. For whatever reason, what grade you're in has an impact on how likely you are to have a license. Now, obviously, we know the age of seniors is usually over 16, the age of freshmen is usually under 16, and that has a lot to do with this. But in this example, we would say, yeah, there's an association. We'd compare those, and we compare the numbers. If they're the same, there is an association. If the numbers are different, there is an association. Again, these numbers are different. There is an association. So that is, in a nutshell, these accompanying notes for the two-way table. If you have any questions, feel free to reach out. Have a good one.